Hello everyone. I hope you all are doing good. And how are you all? This is your physics mentor this side, track 2 physics mentor Charu Sharma. And also I hope you have done with your homework and also you are done with the part 3 video on gravitation. So today we will be discussing, I think today will be the last video of the gravitation chapter. Okay, so today we will be discussing about two important topics, escape velocity and orbital velocity, and some more concepts about satellites. Okay, so let's start with escape velocity. So in the last class I told you about potential energy, and I also briefly told you about d E is equals to dv divided by dr. I completely explained how to use this formula, and also I told about gravitational potential energy, which was a scalar quantity, and its application. I gave you a homework also on 4 particles placed on the square side. Okay, now coming to the escape velocity. So on escape velocity, what does escape velocity mean? From its name only we can find the definition that it is a velocity which is needed for a body to escape from the gravitational field. Okay, so suppose on the earth you are having a gravitational field, and for this mass, small mass m, you want to throw it with such some velocity so that it will never return back to the earth. If it will be get lost to a infinity distance, it will never return back to the earth. So with what velocity you should throw so that this will escape from the gravitational field of the earth? This is known as escape velocity. So there is a small concept for escape velocity, that is your total energy should be turning to zero. Your total energy should be turning to zero when you want to find the escape velocity. So for escape velocity, the total energy of the body should be zero. So how do we write total energy? Total energy is equals to potential energy plus kinetic energy, right? Total energy is equals to potential energy plus kinetic energy. Now for this body mass m, if it is placed on the surface of the earth, what will be its potential energy? In last class I told you how to find potential energy. Potential energy will be equal to, with minus sign, g m, mass of the earth is capital M, small m is the mass of the body, divided upon the distance it is. So it is at a r distance because it is on the surface. So let us take this distance as r, radius of the earth. So r divided by r. I will write again neatly. So potential energy is equals to minus g m m upon r. Okay, clear? Now coming to kinetic energy. Kinetic energy, what will be the kinetic energy of this body? Because I want to throw it with a velocity v so that it escapes from the gravitational field of the earth. So kinetic energy in terms of velocity, how do you write? Half into mass of the body into its velocity. Now as the velocity should be our escape velocity, so I will write it as ve whole square. Okay, so this was your potential energy and this was your kinetic energy. This should be added and the whole sum should be 0. So potential energy minus g m m upon r should be plus half m v e square should be equal to 0, because total energy we need to consider 0. So if you send this potential energy to that side, minus sign will go. Half m v e square is equals to g m m upon r. So small m gets cancelled. So ve is equals to under root of 2 g m capital M upon r. So capital M is the mass of the earth and r is the distance, radius of the earth. So you can see that the escape velocity here is independent of your body. whatever the body mass it is, whatever body you are taking, it is independent. Escape velocity will only depend upon mass of the planet and radius of the earth, or the distance it is from the center of the planet. But it will not, escape velocity for a body will not depend upon that body's mass. So either you take a small ball or either you take a big satellite, both escape velocity will be same only if they are projected from the same planet and the same distance. So it will not depend upon their mass. Also you can see, suppose if I project this body from here or anywhere I project, if it is on the surface, and if I am projecting here from 30 degrees unko, and from here I am projecting at 45 degrees unko, from here 30 degrees, from here 45 degrees, will there any be change in escape velocity? No, there won't be any change. Why? Because our escape velocity is independent of any angle. It is under root of 2gm upon r. Okay. So like that application, on based on these applications, they will give you in question, like one body is projected from planet of earth at 30 degrees, another body is projected with escape velocity at angle of 45 degrees. So who will escape, or else like that they will ask. So you should say both will escape, because it will not depend upon angle. So your escape velocity V is equals to under root 2gm upon r. This is your escape velocity. It will not, it is independent of mass of body projected, whatever body you are projecting, mass of body projected. Also it is independent of angle of projection, angle of projection. So it is independent of mass of body projected. Also it is independent of angle of projection. Easy, I hope. And one more data, sometimes directly numericals they may ask, what is the escape velocity for a body to be projected on earth? So already calculated, it is 11.2 kilometers per second. So if you want to escape a body from planet of earth, like it should never return back to the earth. Suppose you are playing cricket and you want to, suppose you are playing cricket and you want to hit your ball with this bat. You are playing cricket and you want to hit your ball with this bat at such a speed that its ball should never come back to the earth. Okay, it should get lost in the universe. Then what should be the velocity which you should hit the ball? That should be 11.2 kilometers per second. Okka second lo 11.2 kilometers it should cover. Okay. So this is not humanly possible. It is only possible through machines. Don't ever try to put a shot of 11.2 kilometers per second. Okay. So on this escape velocity, there are three cases now. One is your escape velocity case. One more case will be you are projecting with some velocity, but that value of that velocity is less than escape velocity. Then till where our body will go, till what height it will reach, like that questions may be asked. Or sometimes your velocity value is much more greater than the escape velocity also. Okay, it is much more greater than the escape velocity. Then what will happen to the body, where it will go? So like that three cases you have. One is with escape velocity, which already told. Next the case is when your velocity is less than escape velocity, or your velocity is nth times, 1 by nth times of escape velocity. So whatever velocity you are projecting, it is 1 by nth times of your escape velocity. Okay, so and here your velocity is greater than escape velocity, and it is like you, okay, sometimes they may give that the velocity is n times of escape velocity, but this is very rare. They will just give velocity is greater than escape velocity. So like that three cases are possible. So we are going to discuss on these three cases now. Okay. So the first case is your velocity is less than escape velocity. So this is our case number 1. Okay. Okay. So in this cases, instead of solving part, you need to remember the direct results. Now in the case 1, see, your escape velocity, whatever velocity you are projecting, it is less than the escape velocity. Now the whatever velocity you are using, it is less than escape velocity. Means what? That our body will not escape from the gravitational field. Suppose this is your earth and this is its gravitational field up to this much area. So you are projecting with some velocity which value is less than escape velocity. Means this body will not be able to cross the gravitational field. It will be remaining inside the gravitational field only. But up till what height it will go in gravitational field? Suppose like those questions are asked. So see, when this body on the surface of earth it is projected, it is having potential energy, right? How we'll write the potential? So we can say two cases here. Initial, what will be the initial condition and what will be the final condition? What will be the initial condition and what will be the final condition? So see, in initial condition, it will have its potential energy. What will be its potential energy? Now only we learn minus g m upon r. At what distance? It is at the surface of the earth. Okay, so upon r. Next, coming to kinetic energy. And it is projected with v velocity, means it will also have kinetic energy. So half mv square. Okay. Next, coming to what will be its final condition. After reaching some point h in the gravitational field, because it can't escape the gravitational field because the velocity is less than escape velocity. After reaching some point h from the surface of the earth, some distance h may, it stopped here. So it stopped means its kinetic energy here became 0. That's why it stopped. And what will be its potential energy here? Potential energy we write minus g m and at what distance it is. So from center of earth it will be r plus h. So this much distance, no. So this much distance is r. And this distance from the surface of the earth we calculated as h. So r plus h. R plus h. So whatever in initial condition, what is their potential energy and kinetic energy. In final condition, only potential energy is there, kinetic energy is not there. But we know that total energy is conserved always because of law of conservation of energy. Energy is always conserved. So here total energy initial, whatever the total energy you have initially, that should be equal to total energy whatever you have finally. Right? So you equate, you add here potential energy plus kinetic energy. Again here also you add potential energy plus kinetic energy. This is of initial, this is of final. You add it. So minus g m upon r plus half mv square is equals to minus g m upon r plus h. I hope you can see it. No. Okay. R plus h. Okay. R plus h plus 0. Because kinetic energy is 0. So when you will solve this, no, what you will get the value of velocity, I will directly tell you. Because I said you, instead of solving part, you should directly remember the results in these cases. So what velocity value you will get is v square is equals to 2ghr upon h plus r. You can also solve and see, but why I told you the method? Because suppose by the mistake in exam you forget the formula, and this formula is not that important. In this case one, only one more application we will discuss, that formula is important. This formula in very rare cases, and they will not ask numericals directly. This formula only will be in the question. They will tell like one body is projected with a less than escape velocity and it reaches up to a height h from the surface of the earth. Now tell what was that velocity. Means in this term only 2gh r upon h plus r only will be your question answer will be in the options. Okay, very less cases they will ask numericals on this. So if once you have seen the formula, probably it will be in your mind that yeah, we saw this in the lecture and we know this is the answer. or else if you forget, you know how to solve it. You should just equate total energy initial equal to total energy final. Potential energy plus kinetic energy, potential energy plus kinetic energy. So when you solve this part, okay, you will get this V square is equals to 2ghr upon h plus r. Okay, fine, easy. And don't worry, when I will post the gravitation notes, now I am thinking, I did not post the notes on Tuesday because I am thinking I will post whole gravitation together only. Why? Because of what will happen, suppose one day I posted some part of the notes, another day. So when you will want all the notes to be at one place, it will be difficult for you to find, right? Like some photos will be upside, some photos will be in the below the chat, some photos already above the chat. So it will be like misplaced and you will not get a correct set of copies. What is the notes correct in the sequence, you will not get. So I thought that what I will do is, at a once only whole chapter notes I will send in the form of PDF. So that time you can refer how to solve this part, because it is a very long method and I don't want to confuse you. I am not telling solving part is just maths. No, I hope everyone is good at maths. Okay, but by PC students, no, we don't like maths, right? Fine. So this was our case 1. Now in this case only, this velocity is less than escape velocity. Sometimes what they will give you is your velocity, whatever it is 1 by n times of escape velocity. Means it is less only, no? It is still less only, no? It is less only. So in that time, if you apply this formula that V square is equals to 2ghr upon h plus r. So in place of V square, you can write VE by n. So this is equals to VE square upon n square. So that will be equal to 2gr divided by n square. Now why I am writing 2gr divided by n square? See, we know na escape velocity is sorry, one more thing. I didn't say that. Okay, I will first say that part and then we will. See, here, this is very easy. I hope you will get it. G is equals to gm upon r square. This also we discussed. And we also discussed that VE is equals to under root 2 gm upon r. Okay. So sometimes your velocity values will be given in form of this gm upon r. Sometimes it will be given in the form of gr. Only in the form of acceleration your velocity values will be given. So how to get that is, from here you can say that gm is equals to gr square. From here gm is equals to gr square. Just in place of gm you substitute gr square here. So what you will get, under root of 2 into gr square divided by r. R and R gets cancelled. So escape velocity is equals to under root of 2gr. Okay. So escape velocity is equals to under root of 2gr. Now we'll come back to our own case. See, what was our case? That is, whatever velocity is given to us, it is 1 by n times of escape velocity. Okay. So we know that V square is equals to 2gh r upon h plus r. So in place of V square, we can write VE square upon n square. In place of V square, can I write VE square upon n square? See, VE square upon n square is equals to 2ghr upon h plus r. Now only I told you that V is equals to under root of 2gr. How I got that? In place of gm I substituted gr square and so I got this, right? I told you just now. So in place of VE square, if I want, so VE value is under root of 2gr. But here what we have, VE square. So when you do under root of 2gr whole square, this root and square will get root will be get cancelled with that square now. So we will get here 2gr, right, divided by n square. I hope you understood how I got here 2gr. VE is escape velocity is equals to under root of 2gr, and I told you how to derive this, how escape velocity is equals to under root of 2gr. I just now told you. But this is under root and here we have square. So I hope you know the maths, that this root will get over with this square. So 2gr you will get, right? 2gr in place of escape velocity will get here. N square as it is equals to 2ghr upon h plus r. So 2g gets cancelled, r gets cancelled. So you will get 1 by n square. 1 by n square is equals to h upon h plus r. Right? 1 by n square is equals to h upon h plus r, or in simplification you can write height is equals to, this will go this side, multiplied by this, minus 1 you will get. So you will get as r upon n square minus 1. Just you need to solve, or else with this formula also can you work on. Okay. So when it is given that whatever velocity you are projecting, it is less than escape velocity, and it is equals to, suppose like your escape velocity was 25 unko. Okay, your escape velocity was given as 25, and your given velocity, whatever the v value is given, it is said 1 by 5th times of escape velocity. So in place of escape velocity you have 25. So n value is what? N value. This n value is equals to 5, right? 1 by 5 times of escape velocity it is given in the question. So n value, if you get n value, you get as 5 from the thing, from the what I say question. It is only given that given velocity is 1 by 5 times of escape velocity. So n value you got as 5. So just to substitute, 1 by 5 square is equals to h by h plus r. R value is given on R value is given as 32 kilometers. For example, can you find h value? Because you have now n value, you have r value, you can find h value. Okay, so like that questions will be there. Like till up to what height your body will go when it is projected by 1 by 5 times of escape velocity. Like that questions will be asked. So this was your first case. I hope I was very clear. Okay, if you have little problem, just rewind back and watch the video again. Now for example, it is given that your velocity is greater than escape velocity. Now your velocity, whatever you are using, it is greater than escape velocity. That time again you need to follow the same concept, that total energy initial is equals to total energy final. Again same concept. But here, as the velocity is greater than escape velocity, it means that after reaching infinity distance, after reaching, like from Earth, it has crossed the gravity, because its velocity is greater than escape velocity, means what? The value up till which it is equal to escape velocity, that part will be used to reach a infinity distance. But after reaching some infinity distance also, crossing the gravitational field, after reaching some infinity distance also, still the body will have some leftover velocity with it. That we will say as velocity at infinity. That we will say at final velocity, velocity at infinity. Because the case is, second case is, our given velocity is greater than escape velocity. Once it is greater than escape velocity, means that after crossing gravitational field, it will reach infinity distance, but after going infinity distance also, it will have some leftover velocity with it. Just that's it. Now what was the total energy initial? Potential energy plus kinetic energy is equals to potential energy plus kinetic energy. Potential energy is what? Minus g m, because at surface of Earth, so r, plus kinetic energy is what? Half mv square, we are projecting with this velocity, is equals to, what will be potential energy? It will be at infinity distance, so minus g m upon r plus infinity. Plus what will be kinetic energy? It will still have some velocity, so means it will still have some kinetic energy, that will be half m v infinity square, because I told you v infinity will be the velocity at infinity. Some velocity it will have, na? So with that v infinity I am representing that velocity. Okay, so when you will solve this, what you will get? Minus 2gm 2gm upon r square multiplied by r plus v square. Okay, minus 2, so I'm solving, just I took LCM and like that only I'm doing. Okay, is equals to, here so this term will get cancelled because r plus infinity no meaning, small m masses gets cancelled, so is equals to v infinity square. That's why I did not write small m, because small m everywhere it will get cancelled. Okay, so you know that this value is equals to what? Tell me. 2gm upon r square. What is this? Not 2gm upon r square. This r also will get cancelled now, so here only will be remaining with r, right? So 2gm upon r, what it is? Tell me. Is it not ve square? Because we know that escape velocity is equals to under root of 2gm upon r, but we here have 2gm upon r. 2gm upon r means if you square this you will get 2gm upon r only, no? So is this value not equal to ve square? Yes, it is equal to v square plus v square, whatever the velocity you got is equals to v. I'm just solving it, okay? V infinity square. I'm not doing anything great. Just this part I am solving. Small m will get cancelled. Then I did LCM and got 2gm upon r plus v square is equals to v infinity square. Then I saw that 2gm upon r is nothing but ve whole square, escape velocity whole square, because we know that escape velocity is equals to under root of 2gm upon r. Now escape velocity को whole square करे तो यही आता ना 2gm upon r. So I instead of that I mentioned v square. Again v square as it is, v infinity square as it is. So from here what you will get, so in this type of questions, you know what they will ask, when the escape velocity was when whatever velocity we used it is greater than escape velocity, then after reaching infinity distance what will be the velocity. So I told you we will represent that velocity with v infinity. So from here, from this you need to find v infinity only. So v infinity is equals to under root of, this will be minus, no? Here minus sign was there, right? Minus. So v infinity is equals to v square minus ve square. So after reaching infinity distance, how much velocity will be left over? That will be equal to under root of, with how much velocity projected, square of that minus escape velocity ka square. I hope I was very clear. Okay. If you didn't understand, just rewind the video back. You will surely understand it once again, okay? And always when I am explaining, I always told you that take a rough paper beside you. Always take a rough paper beside you and keep solving together. So you will understand what is happening. If you just see like a movie is going on, then probably something will go in your brain. And it won't be interesting also. So in escape velocity, we discussed 3 cases. The first case was escape velocity itself, that is equals to under root of 2gm upon r, and also it is equals to under root of 2gr. I told you how we got this 2gr. How we got this 2gr? Because g is equals to gm upon r square. So instead of gm, you put gr square here. Instead of gm, you put gr square here. Gr square is equals to gm. So this gr square if you put here, 1r will get cancelled, you will be remaining with gr, so that will be under is equals to under root 2gr. The second case will be your velocity is less than escape velocity. Either like that it's given, means v square is equals to 2ghr upon h plus r, this v square value. Or else if it is given like v is equals to 1 by n times of ve, then what will be the height? It will be equal to r by n square minus 1. We already derived it. I showed you how to derive that. Okay, I'm just giving the revision. The third one was when your velocity is greater than escape velocity. When it is greater than, then what will be the velocity at infinity distance? Means v infinity is equals to under root of v square minus ve square. Okay. Sometimes you know what they will give in this cases, that v is, I told you that case is very rare. In third case, sometimes what they will give you, that your velocity is greater than escape velocity. Okay, fine, it is greater than escape velocity. But this velocity is equals to k times of escape velocity. Then what is v infinity? They will ask you. That time v infinity is equals to under root of v square minus ve square. So instead of v square, I can put kve square. Kve whole square minus ve square. So ve square I will take common in under root. So ve will come outside. Ve will come outside. And here you will have k square minus 1. Okay, so this will be your v infinity. This will be your velocity at infinity. I hope I was clear. Easy. Easy peasy lemon squeezy. Okay, so coming to the second topic of today's class, that is orbital velocity. Orbital speed or orbital velocity. So by definition, orbital velocity is the velocity required for a body to revolve in a orbit around a planetary body. For example, this was your earth. This was your earth. So around the earth, how many bodies are revolving? You can know. Moon is revolving, many satellites are revolving. So what these satellites should have the velocity so that they can revolve in a particular orbit around the earth at a particular distance. Okay, that is nothing but your orbital velocity. So how do you find this orbital velocity? Now I just said it is just a application. Already this is said before, that when something is revolving around something, means it is revolving in a circular path. So once it is revolving in a circular path, what will be the reason for that? Centripetal force. So centripetal force is not a new force, it is resultant of some force. So here between this planetary body and the earth, what is the force that already exists? That was gravitational force. Then centripetal force is also equal to gravitational force. So centripetal force is equals to gravitational force. Now our mass is of earth is of mass capital M, then radius is capital R, and this planetary body is at a distance h, or the radius of this whole circular path we can consider as small r. The radius of this whole circular path we can consider as small r. Again I will draw the diagram, don't worry. This is our earth and it is having capital R as its radius and mass as capital M. Okay, and this is a circular path from the center of the earth till this orbit distance we will consider r. The radius of this circular path is r. So what will be centripetal force? mv square upon r. So what is the v velocity over here? The velocity whatever the body is possessing to require orbital velocity only. So mv square upon this r, small r, is equals to gravitational force g m into this r square. Na? This is the distance between two masses. Product of two masses divided with the square of distance between them. So from here I am writing for clarification, this is orbital velocity as VO. So VO is equals to small m gets cancelled, RR gets cancelled, equal to under root of gm upon r. Okay, so this is your orbital velocity. Which velocity? Orbital velocity. Now in place of gm, again if you write gr square from this formula, g is equals to gm upon r square. From this formula, in place of gm, if you write gr square, you can get v naught is equals to under root of gr. Okay, v naught is equals to under root of gr. You will get it. Right? Easy. So if sometimes relations may be asked between escape velocity and orbital velocity. So escape velocity was equals to under root of 2gr and orbital velocity we got as under root of gr. So from directly you can say that escape velocity is root 2 times of orbital velocity. Means how many times more? 1.414 times more it is than orbital velocity. Root 2 ka value is 1.414, right? Suppose if they ask how much excess percentage of velocity require a body was revolving. Suppose a question is asked, nice question it is. Suppose a body is revolving around Earth with orbital speed v0 with v0 in a fixed orbit. In a fixed orbit. Now, how much excess percentage of velocity require to escape from Earth gravitational field? From Earth gravitational field. Like this question is asked, for example. Okay, a body is revolving around Earth with v0 in a fixed orbit. Now how much excess percent of velocity required to escape from Earth gravitational field? So you know that escape velocity was under root of 2gr and orbital velocity was under root of gr. Now excess percentage means what? If I write ve upon v0, that is equals to under root of 2gr upon under root of gr. That will give you as under root 2. Right or not? It will give you as under root 2. Okay, clear? So excess percentage. Excess means you should do v0 मतलब excess ना कितना ज़्यादा है, कितने percentage ज़्यादा है. So ve by v0 minus 1. This is equals to root 2 minus 1. Both side you should do minus 1 minus 1. So here we will get v0 minus ve minus v0 upon v0. This will be like fraction only, no? How much fraction divided by the original value is equals to root 2 minus 1. Root 2 minus 1. I'll keep it as root 2 minus 1 only. Okay, or else you can write as 1.414 minus 1. Okay. So percentage is asked. So for percentage both side multiply 100. Because percentage is asked. So ve minus v0. So I can say the fraction, the excess fraction percent is equals to 1.414 minus 1. This will be equal to 0.414 into 100. So it will be, due to 100, the point will be shifting this side. So answer will be 41.4%. So how much excess velocity required? 41.4% of excess velocity required. Okay, easy. If you didn't understand, just rewind back and listen again. And don't worry, notes will be posted at once. Okay, I will not be posting part in part because that will be making the thing very confusing. Fine. Now coming to a small concept, energies, total energies, kinetic energy, potential energy. Always remember the ratio. Okay, energies. So always remember the simple concept. Firstly, I will explain this one. Actually, it is wrong method. Because first I should tell what is the value of total energy, what is the value of kinetic energy, what is the value of potential energy, then I should find the ratio. But I will always feel that is more confusing, you know. If you know this one, that is more easier. So I said you in starting the first part, eccentricity wala, when in the problem solving video is there, no, one problem solving video on gravitation. In that I told you eccentricity. What is the role of eccentricity to know the path is eclipse or circular, and it depends upon total energy also. So because of its eccentricity, here we should take total energy in negative terms. And potential energy we already know it is negative. And kinetic energy will be positive. Okay, always increasing. So total energy is negative, kinetic energy should be positive, potential energy should be negative. Now total energy is like whole energy now, so you should tell it as minus 1. And always the numerical value of total energy and numerical, just the magnitude, just the magnitude for the total energy and kinetic energy will be always equal. Only sign will be opposite. So this will be +1. Now you only tell me what should come here. To if I add these both, I should get total energy value as -1. So I should be here as -2. Na? -2 plus 1. If you add these two, kinetic energy plus potential energy, then only total energy will be coming as -1. So this you should always remember. If total energy is -1, kinetic energy is +1, potential energy is -2. Like this ratio you should always remember. They will somehow jumble and give in the question. But you should have the simple concept. Total energy is -1, kinetic energy is +1, potential energy is -2. But how it came also I will explain now. Okay. So we know that our potential for a body, suppose this body, this is the circular orbit, here is our earth, this is our body of small mass m at a distance h from the surface of the earth, and earth ka radius is r and mass is capital M. It is revolving in a circular path. So what will be its potential energy? Minus gm upon r plus h, because the distance r plus h from the center. Next, coming to what will be its kinetic energy. Its kinetic energy will be plus half mvo square. Why vo square? Because orbital speed I am considering, vo square. Okay. Now this I will write in terms of this type, like minus gm. In terms of gm I will write kinetic energy. How to write like that means, see, in place of orbital velocity v naught, can I write under root of gr? I can write, no. So I will write like that, half into m into under root of gr. But whole square means only gr will come. Right? Only gr will come. Now, in the place of, we will write g is equals to gm upon r square. We know that, right? We will write like that only, half into m into gm upon r square into r gets cancelled, gm upon 2r. But this r is the distance, right? It is the distance. Now here the distance is r plus h. This r should be the distance, I told you before also. So this should be r plus h. Okay, right? In starting I consider a radius, but it should be distance. So r plus h you got. Instead of again and again writing r plus h, I am considering r plus h is equals to small r. R plus h is equals to small r I am considering. Okay. R plus h is equals to small r I am considering. So here I can write minus gm upon small r. I can write. And for kinetic energy also I can write gm upon 2r. Okay. See, in place of r plus h, I am writing small r. That's it. Okay, I hope this part is understood. See, V2 kinetic energy half m v naught square, orbital velocity. Now, just for solving part, I kept distance as simple r. But actually, distance is r plus h. No, that's it. I wrote last mein r plus h. Okay, everywhere it should be r plus h like that. Instead of writing again and again, I kept here r only. Okay, that's it. Don't worry. So, kinetic energy is equal to gm upon 2r. So, remember the results. This is potential energy. Now, one thing. Wait. So, you got your potential energy as minus gm upon r and kinetic energy as minus gm upon 2r. Okay. So, if I add these two, if I do sum of these, I should get total energy. That is potential energy plus kinetic energy. So, if I do sum, potential energy is minus gm upon r plus, why did I write minus here? This is not minus, sorry. Gm upon 2r. Okay. So, this is gm upon r, these all common only. It is minus 1 plus half into minus 1 plus half into gm upon r. So what you will get? Minus 2 plus 1. minus 2 plus 1 is what? So you will get minus 2 plus 1. It's minus 1 divided by 2. So you will get minus half. Minus 1 plus half is minus half, no. That is equals to GMM upon R. So this is your total energy value. So what did you get? Total energy. Total energy is equals to minus half GMM upon R. Now you see kinetic energy was plus GMM upon 2R. Total energy is minus 1 GMM upon 2R. Okay, same values na, only sign is different. That's it. So if you take this ratio, potential energy will get as minus 1, kinetic energy will get as plus half, and total energy ratio will be minus half. When you solve this, in potential energy you will get minus 2, in kinetic energy you will get plus 1, in total energy you will get minus 1. That is what in starting I explained you. Okay, here I took potential energy, this is kinetic energy, and this is total energy. See, always kinetic energy and total energy values will be same. Only the sign will be opposite. For total energy it will be negative. For kinetic energy it will be positive. Okay, easy. The ratio you can remember now. Just remember potential energy is minus 2, kinetic energy is plus 1, and total energy is minus 1. So I hope that was clear. Okay. Now what else we have? Just about satellites, everything I explained you. See, one application about satellite they will ask you. See, suppose this is your orbit, here is your satellite, this is your earth the satellite, this is our satellite, it is revolving around the earth. So about angular momentum, one thing they will ask you. See, angular momentum, I told you in my first class only what was angular momentum. Momentum into perpendicular distance. So here perpendicular distance is nothing but this radius only r, and this is momentum direction in the direction of velocity. So mv into r perpendicular distance. Okay, so this v is nothing but your orbital velocity only, no, v naught. This orbital velocity you can write in the terms of gm upon r, no, gm upon r. So if I substitute this only, v into under root gm upon r into r perpendicular, you can see that this r and this value, this is only radius, and again for v naught also this is only r, this distance is only r, and for r perpendicular also this distance is only r. So r perpendicular means, see na, your momentum value is in this direction, p direction is this, because it will be in direction of velocity, and mass doesn't have any direction. So perpendicular to this is only your radius. Okay, this is only the perpendicular. So this r only you should consider for orbital velocity, this r only you should consider for r perpendicular. So when you take that, and again I can take this in root, I will take as g m r into r square. Under root I will take this inside the root, r will get cancelled. So m outside g m into r is equals to angular momentum L. So sometimes they will ask you L is proportional to what? So here you can say L is proportional to r to the power half. Why? Because r is under root. Okay, like that application may be asked. What else next? Everything I told you. Geostationary satellites. What are geostationary satellites if they ask you? About geostationary satellites, they will have a time period of 24 hours. Okay, and direction will be west to east. So in geostationary satellite are the satellites which will revolve around the earth. Okay, and the direction will be west to east, time period will be 24 hours. Okay, like these questions sometimes you will see in your objective. One more thing I wanted to tell you. See, sometimes now this potential energy, we discuss the formula in terms of gmm upon r, na. Sometimes this formula will be given in terms of mgr. How means? See, in place of gm you should just put gr square. From this relation, g is equals to gm upon r square. So when you put that, what you will see, gr square into m upon r. R gets cancelled, it becomes mgr. So sometimes your potential energy, kinetic energy will be terms of mgr. Okay, sometimes. So questions will be, your options will be in terms of mgr, means you know how to get it into terms of mgr. Okay, everything I told you. Anything else? No. And one more thing, work done. Sometimes work done questions are asked. Suppose it is at a height h1, then at height h2, what is the work done? Just you need to find difference between the final energy minus initial energy. Okay, in the question if there is nothing mentioned about velocity, then consider these final energy and initial energy in terms of potential energies only. What is potential energy in the first case, what is potential energy in the second case, just minus final potential energy minus initial potential energy. And I already told you, don't forget the minus sign, again you will get a wrong answer. Just remember minus sign for with potential energy. So final potential energy minus initial potential energy. If velocities are mentioned, that in the first starting point it was having v velocity, after reaching h2 distance velocity became 0, that time what you take in we did not till now for sk velocity, final energy is equals to initial, total energy is equals to potential energy plus kinetic energy, again initial energy is equals to potential energy plus kinetic energy. So those additions you do, whatever you get here, potential energy plus kinetic energy, here also potential energy plus kinetic energy, then from final energy you subtract initial energy, whatever the value is you get, that is the work done value. So final energy minus initial energy is work done, always remember this. And don't forget to take minus signs for potential energy, so you will get a correct answer. So we are done with gravitation chapter. Okay, and now tomorrow I will be posting the notes, and again few problems also I will be posting. And as usual, if you have not still read NCERT, please take a time till Sunday and complete your gravitation chapter ka NCERT, whatever chapters are going on the channel, complete their NCERT back problems, at least do the sums of NCERT perfectly, then whatever module you are having, you do those sums. Okay, have a good day, bye, tata, see you.